Okay, so in this lesson, we are going to be talking about the difference threshold, which is slightly different from the absolute threshold. You'll remember that the absolute threshold was the smallest amount of energy necessary to detect the presence of a single stimulus. The difference threshold is the smallest amount of energy necessary to determine the difference or detect the difference between two stimuli. So this can be a little bit complicated. Sometimes the difference threshold is called the Difference Limen, or the DL, and you can observe the Difference Limen when you are comparing the perception of two stimuli, one against the other. So the smallest amount of difference between those two stimuli that's noticeable is the Difference Limen. And that doesn't necessarily mean that the Difference Limen is close to zero. It can be pretty big. But the smallest amount of difference between two stimuli that's noticeable is the Difference Limen. So here's an example of how you might measure the difference threshold. Let's say you were interested in the ability to detect the difference between the length of two lines. So here we have a red line and a blue line, and we're going to present different length red lines. We're going to keep the blue line constant. We're going to present different length red lines. And every time we present a new red line, we're going to ask the subject, is the red line longer than the blue line? Is the red line longer than the blue line? And we're going to plot the results on this psychophysical axis. Again, on the x dimension, we have the physical dimension of the length of the red stimulus. And on the y-axis, we have the proportion of responses that were yes. So remember, the question is the red line longer than the blue line? And we're going to plot how many times people say, yes, the red line is longer than the blue line. So whenever we present a red line of this length and we say, is the red line longer than this blue line, most of the time people are going to say no. So the proportion of responses that say yes is represented by this purple dot here. How many times do people say, yes, the red line is longer than the blue line when the red line is that length? 0% of the time. Now, as the red line gets longer, the amount of times that people say that the red line is longer than the blue line will increase. Now, you might be wondering, how on earth could they say that the red line is longer than the blue line here? Don't forget that these are being presented on a screen very, very quickly, and people have to make responses very, very quickly. So the closer the red line is to the length of the blue line, the more often people are going to say, yeah, the red line was longer than the blue line. Now, at a certain point, the red line becomes exactly equal to the length of the blue line. But remember, we're only asking people, is the red line longer than the blue line? They either have to say yes or no. If they're exactly equal, they have to say yes or they have to say no. So you should expect that half the time they'll say yes, the red line is longer than the blue line, and half the time they'll say no, the red line is not longer than the blue line. And that's represented here by 50% with this purple dot. And then as the red line continues to get longer and longer, it is now always longer than the blue line physically. People will detect that it's longer more often until by the time the red line is at its full length, it will 100% of the time be detected as longer. Now on these axes, they've also plotted with the green dots the number of times people say the red line is shorter than the blue line, and that goes exactly opposite to the purple line. So once we connect those dots, the red line now represents the proportion of times people judge the red line to be longer than the blue line. And you see that down here, when the red line is really short, it's 0%. When the red line is really long, it's 100%. And it's graded in between. And the green line is just 1 minus that. How many times do people say that the red line is shorter than the blue line? 100% of the time when it's really short, 0% of the time when it's really long. And the meeting point is halfway, where they're exactly equal to each other. Now, the point of subjective equality is the point where they are judged half the time to be longer and half the time shorter. Subjective equality means psychologically, do they think that these two lines are equal to each other? And when they split the difference, when they say half the time it's longer, half the time it's shorter, that means they can't tell. The difference Limen is taken to be the difference between the point of subjective equality and the point on the curves where 75% or more of the time they are saying one item or another. So at this point here, 75% or more of the time when the red line is longer than this point here, people will say the red line is longer than the blue line. In between here, they're not reliably saying that the red line is longer than the blue line. And that difference is called the difference threshold. It means that when the red line is somewhere in between these lengths, they're not consistently saying that the red line is longer. In other words, they're unable to reliably tell the difference between them.